All right, today's lesson is 6.3, solving equations using multiplication or division. Now the volunteer read the learning target for us. Mia?
I can write and solve equations using multiplication and division.
Awesome, thank you. So one little definition before we begin is the multiplication property of equality. This says when you multiply each side of an equation by the same non-zero number, the two sides remain equal. So if you multiply both sides of an equation by something that isn't zero, the sides will stay equal or stay balanced. So just like yesterday, learning that whatever you do to one side, you must do to the other if we want it to stay balanced and equal. So like this equation here, showing that when you multiply both sides by 4, you get something that is still equal. So we're going to go ahead and test that out on example 1a. Step 1 is drawing a line through the equal sign. And yesterday, there was a student who asked me, like, why do we have to do that? Does anybody think they know why we do that? Technically, you don't have to. It doesn't, like, change anything, but why might it be helpful to do that? Logan? Yes, it keeps the two sides very clear and helps you make sure you're doing the same thing to both sides. In the past, I've had students that say, no, I don't need to do that. I can show my work on both sides anyways. And then what they end up doing is like doing the same thing twice to the same side. They kind of forget where that separation point is and that the equal sign is what separates the two sides. So drawing the line helps you very clearly see these are the two sides. Because sometimes students will think that like a minus or a plus sign is what separates the two signs, but it's always the equal sign. That's what shows you the two separate sides. So that's why we draw a line to organize our work. Remember, a solution is figuring out what the variable equals. So I want to know what W equals. But right now it says W over 4. What does W over 4 mean? That's like a fraction. What operation is happening? Emma? Correct. So if W is being divided by 4, how do you think I undo or get rid of divided by 4? Dash?
Multiply by 4.
So I'm going to write times 4. Notice that I used a dot for the multiplication because if I use an X, I might start to get confused and think there's like the letter or variable X in here. That's why I'm using a dot. This divided by 4 and times 4 undo each other and leave us just with W. We isolated the variable. Wow, got it by itself. But my scale has now tipped because I multiplied one side by 4. So what do you think I do to the other side to make sure it doesn't tip and it stays balanced? Aaron? Yeah, times 4. 12 times 4 is 48. And that right there is my solution. W equals 48. Remember, it must say the variable equals a number. Circling 48 is not a solution. It has to say what equals 48, and it's W. And then what did we do yesterday after we got the answer just to make sure we did it correctly? What was that like step we did at the end just to make sure we did it right? Yeah?
Put 48 in place of the W and see if it works.
Yeah, so I'm going to write 48 over 4. Does that equal 48? Or not 48, my goodness, 12. It says 12. This is my check step. And then one thing I didn't really mention yesterday, but that's really important. When I write this down, a lot of times what students do is then right underneath it, they just go, oh yeah, 12 equals 12. Cool, I'm good. I have seen students do that on a test. And what they wrote down actually doesn't equal 12. It equals like 8 or something. So when you write it down, actually do the math. Ask yourself, what is 48 divided by 4? It is 12, but you should be actually thinking about the answer and not just assuming it's correct. Because I have seen students write something like 2 times 2 equals 5. And I'm like, they did not. And then they write 5 equals 5. Cool. And I'm like, you didn't think about that. So make sure when you write it down, you actually process what it equals. All right, next one. 6 equals a over 8. Step 1, draw my line to separate the two sides of the equation. Which side should I focus on, the left or the right? Natalie? Why?
wrong because it has the variable.
Yes, so I'm focusing on the right because it has the variable, which is a. Emma told us last time a over 8, that fraction bar means division. So it means a divided by 8. How do I undo divided by 8, Aubrey? So times 8. Divided by 8 and times 8, those things undo each other, leaving only a left over. But now my scale is tipped. What am I going to do to the other side to make sure that it doesn't tip? Farhan?
Might multiply 8, but I did it up because you'll be confused.
And then 6 times 8 is 48. This 48 equals a, that's fine. But I personally prefer to turn it around and write a equals 40. Fabian, do you have a pencil? Do you have a pencil and you're taking notes? There's pencils over there. The expectation right now is that you're taking notes. That needs to come out too. There we go. There's our answer. Remember, don't circle the number 48. 48 is not an answer. It has to say the variable equals 48. And then I'm going to check it to make sure. I'm going to check it by writing a 48 in the place of a. So 6 equals 48 over 8. And I'm putting a little question mark because I'm actually going to ask if this is right. I'm not just going to assume that it's correct. Who can tell us what 48 divided by 8 is? Shelby?
6.
So that means we are good. But you actually gotta just make sure, right? Do 48 divided by 8 and go, is it 6? It is, but you want to double check. You don't want it to equal 5 and then find out you did it wrong. Because then what you would do, what would you do if your check was wrong? Like your check didn't have 2 equal things. Emma? Yeah, it means you did it wrong. Got rid of it. Questions about example 1, A or B? All right, moving on to example 2. This is just going to do the same thing, but we're going to use division. So the division property of equality says when you divide each side of an equation by the same non-zero number, the 2 sides remain equal. So what we have ultimately learned over the past 2 days is whatever you do to one side of an equation, you must do to the other. Please check your homework. Thanks. And that's called the golden rule of algebra. Whatever you do to one side, you must do to the other. That's how we keep equations equal. So starting with this one, 65 equals 5b. I'm going to draw my line to separate the 2 equal sides of my equation. What is happening between the 5 and the b if they are touching and there is no symbol? What operation does that mean? Sandra?
Multiplication.
How do you think I undo the times 5? Shelby?
Putting a dot in between them, like a multiplication.
That's how I can show times 5, but how am I going to undo or get rid of a times 5 if I just want b to be like all by itself? You know?
Divide by 5.
Yeah, and I'm going to use a fraction bar to show my division. If you do the dot line dot division symbol, that is not wrong, but this is just what you're going to continue to see a lot of times from your teachers in the next few years is using this fraction bar for division. Times 5 divided by 5, those two things undo each other, leaving us just with b. What do I do to the other side to make sure my scale doesn't tip though? Because now I've divided this side by 5, I've changed it in some way. Dash?
Divide by 5.
And 65 divided by 5 is 13. And then, like I said last time, I prefer to turn it around and write b equals 13, but either way is fine. And then I'm going to check it and make sure it's right. So I'm going to write down my equation, 65 equals 5b, but where the b is, I'm going to put a 13. And I'm going to put it in parentheses to make sure that I'm showing this means 5 times 13 and not 513. And then just like last time, I'm not just going to say, oh, yep, 65 equals 65, I'm good. I'm going to actually think about what 5 times 13 is. You can tell us what 5 times 13 is. Grayson? So now that we've thought about it and we know it's 65, I do know I'm correct, but we just want to actually think about it. Questions about example 2 then? All right, 2b, I draw my line. That's always step 1. This one is a little bit weird. This one has a fraction directly in front of x. What do you think is happening here? Logan? Yes, it's just being multiplied by a fraction. What happens is a lot of times students go, oh, it's being divided because there's a fraction. If it's a variable over a number, that does mean division, the variable divided by the number. But if there's an entire fraction in front of the x, it means it's being multiplied by the fraction. So to undo it, I'm going to divide by the fraction. So I'm going to write divided by 2/7. And you can see there's a case where I used the dot line dot because I thought it would be weird to do a really big fraction bar and then another fraction under. Times 2/7 and divided by 2/7 undo each other. So all we have left is x. And then whatever we do to one side, we do to the other side. So I'm going to divide this side by 2/7 as well. Now that I have to do like a little bit of work for, so I'm going to off to the side do that fraction division. So I'm going to keep change flip that 6, but I'm going to write it as 6/1 times 7/2. So I just did my keep change flip kind of off to the side. I can cross cancel 6 and 2. 2 goes into 6 3 times and into itself once. When I multiply across, 3 times 7 is 21. 1 times 1 is 1. And 21/1 just equals 21. So that means x equals 21 is our solution. Again, not just 21, but x equals 21. And then I'm going to go ahead and check it to make sure that we did it correctly. So when I check it, I'm going to write down the equation, 2/7x, but where there's an x, I'm going to put my answer, which was 21. And I'm going to write it as 21/1. Does that equal 6? And notice that I put a time symbol in between because when that is touching the x, it means they're multiplied. Now I'm going to actually do the fraction multiplication to see if it's 6. 7 goes into 7 once and into 21 3 times. 2 times 3 would be 6. 1 times 1 would be 1. 6/1 and 6 do mean the same thing, which means you did it correctly. Questions about example 2b? Right. One last one. This is our word problem. The area of a rectangular LED sky screen in Beijing, China is 7,500 square meters. The width of the sky screen is 30 meters. What is the length of the sky screen? Before we do this one, when it says square meters, I've had some questions lately about if that means you're supposed to square this number. No, it's just that any area is measured in not the unit, but the unit squared. Because measuring area is like filling something up with a bunch of squares instead of just measuring like a straight line. But it doesn't mean you do anything to that number. So how do you find the area of a rectangle? You kind of need to know that to set this up. How do you get the area of a rectangle? Which do you do? Aubrey? So the width is 30 times the length, which I don't know, so I'm going to use an L to represent that. What should that equal according to the problem? If I do 30 times whatever the length is, what is that supposed to equal? Who's on here?
7,500.
Yeah, because they told us this is the area, so we know we get there by doing 30 times something. This is an example of how you can use an equation to answer the question. So now I'm going to go ahead and solve it, and I'm going to do that by dividing both sides by 30. Times 30 divided by 30 undo each other, so I just have L for length, and then on the other side, I'm going to do 7,500 divided by 30, which is 250. So the length is 250 meters. I know some of you might go, oh yeah, I actually knew that I would just divide them. That's awesome. This is just showing you an example of the equation that can be used to get there. Questions about anything on our lesson?